Hey team, I'm recording this on Sunday night. You might have noticed that I've got the same shirt on. I kind of got in the zone with the last one. Help of this product placement. I've got a conference call tomorrow regarding year 13 stats, so I needed to do it today. So today we're going to look at the double angle formula, and we're going to use it backwards to find half angles. We're going to do it one problem, two different ways, and there's an extension problem at the end. Okay, so pretty short. Find the exact values of these two expressions. You should notice obviously that 15 is half of 30 degrees, and then 90 plus 15 is 105. Alrighty. First up, that's the double angle formula on the formula sheet. And Wikipedia gives us a whole heap of stuff when you look at the Trig identities page. Go for your life, it's some good viewing. We're not going to use any of those because you don't have those in the exam. We simply just want that as our formula. We change the double angle bit to just alpha, therefore we change all the a's to alpha over 2's. Notice that the structure of the identity doesn't change. The 2's and the squareds, they stay the same. Some people would think that, oh, if we're losing the 2 on the left, we're going to get rid of those 2's, but it doesn't work like that. You can only change angles. So if we rearrange that formula, we actually get a quadratic in tan of alpha over 2, so we can use the quadratic formula. And when we do that, we now have a half angle formula. Meaning if we've got the value of tan alpha, then we can find the value of tan of alpha over 2. So we do that. Tan of 15 degrees, we need tan of 30 degrees to find that. Fortunately, that's one of our special angles. 30 degrees is pi over 6. Tan of it is opposite over adjacent, 1 over root 3. So we replace all of the tan 30s with 1 over root 3's. 4 over 1/3 is 12. 12 plus 4 is 16, so that's nice. Square root of 16 is 4. I take the positive root for that. 15 degrees is in the first quadrant. Tan is positive in the first quadrant, so I need a positive answer. If you type on your calculator tan of 15 degrees, that will be the decimal. That's the exact version of the decimal you'd get. All right, for the second part, I did say at the start that if we just add 90 degrees to 15, we'll get 105. Bit of a problem with the formula here. Tan of 90 degrees is not defined, so we can't use this formula. That's where the asymptote of the tan function exists. So we need to be a bit cleverer with our angle choices. 45 plus 60 will do the trick. Sub in 45s and 60s into here. We get this nice exact expression. Rationalize it, we get minus 2 minus root 3. Alternatively, if you really want to stick with your 15 plus 90s, then you can, but go via the sine and cosine function because they're defined for all angles. They have no asymptotes. Cosine 90 is 0, sine of 90 is 1, so this simplifies quite a lot. So to find tan of 105, we just need the cosine and the sines of 15. That's cool because we've already got the tan of 15. Draw a triangle again, this time 15 degrees, 2 minus root 3 over 1, that came from before. To find cosine and sine though, we're going to have to find this hypotenuse, and it's not a nice expression. It involves surds. So instead, just recognize we need negative cotan of 15, the reciprocal of tan with a minus, and that gives us our answer. Alternatively, this is quite a common thing that appears in scholarship. These half angle formulas delivered in a different way. I'll just show you one example. If we make a triangle here and we make our angle theta over 2, and we make the substitution t equals tan theta over 2, then this is our triangle. Sine of theta is just, using the double angle formula, is just this. And then we can get all of that from just trig ratios off the diagram, and there we go. You can do the same thing for cosine, and therefore tan is just sine over cosine. And then that's a similar thing if we rearrange it, because really we want to solve for t. We know what tan of theta is. We knew that it was tan of 30 degrees, and we just want t from that. Okay, last up, this is the extension question. Hence or otherwise, you can use the information on that previous slide to solve this problem. That makes it a whole heap easier, turns it into a quadratic. Good luck.